Assalamu alaikum warahmatullahi wabarakatuh. These days, when we are going to the university, hospital, or even to the mall parking building, either we find a place to park our car or the parking building is full. From this point, we can define the people into three kinds. The first kind of people who find an empty slot in the parking building and they park correctly, or they found the parking building is full and they are looking for another place to park. This is what people must do. The second kind of people who find an empty space, but instead of parking in only one parking slot, they take two parking slots. The third kind of people who find the parking building is full and they are blocking other people's cars. So, what is our objectives of doing this project? The low-level objectives or technical objectives of this project are 5. The first one is utilizing the parking lot efficiently. The second one, saving people times by decreasing the report time of wrongly parked car. The third one is to detect and report wrongly parked car. The fourth one, decrease the crowdedness in the parking building. Fifth one is to make a solution that automatically reports a legally parked car. For the high-level objectives or long-term objectives are also 5. The first one is to support the automation. The second one, make people commit to rules. The third one, help the economy through efficient use of technology and infrastructure. Fourth one, decrease car emissions while waiting and searching. And fifth one, and finally, increase a sense of harmony due to fewer violations. Now, how we are going to solve this problem? Let's see together.
To solve this problem, we will distribute smart cameras in the parking building. These cameras will contain a car detection model and an algorithm to detect wrongly parked cars. Additionally, there will be 2 types of cameras. One will detect double parked cars and it will cover 4 parking spaces, while the other type will detect blocking cars and it will cover the middle row of the parking building. Whenever a violation is detected, the smart camera will send the information to the database to be stored, and to make it easier for the security, a graphical user interface will be created, which will provide a violation notification and database management functionality. In double parking detection, the camera will be placed at a position that only shows 4 cars. Whenever a frame is taken, it will first go through the detection model to detect all the cars in the picture. Also, the image will be divided in 4 regions, which represent the 4 parking areas. The double park detection algorithm will detect the overlap between the bounding blocks and the parking regions. And from the overlap, the algorithm will decide whether the car is double parked or not using a threshold. If it happens that a double park is detected, the algorithm will keep track of the violation, and if the car is still taking 2 parks for 30 seconds, then a report will be sent to the security.
When we designed the blocking cars algorithm, we faced the challenge of hardware limitations, which is solved by writing a simple code that does not take much space from the memory. Even though there were many methods to determine moving objects, such as frame differencing, optical flow, or background subtraction, we choose the simplest, which is finding the distance between bounding boxes into adjacent frames. For example, the camera will capture 2 frames that have several cars. The algorithm will find the distances between all the cars in frames 1 and 2, comparing it with the threshold. If the distances are greater than the threshold, this means there is no parked car, and the next frame will be captured immediately after 1 second. On the other hand, if one of the distances is less than the threshold, the algorithm will take the decision that the car is parked and it will store its position. The next frame will be captured after 30 seconds. After 30 seconds, if there have been parked car within the position that was already stored before, it will assume that the car is the same, and it will wait for another 30 seconds. The loop of waiting 30 seconds will continue until either the car leaves and it is not detected anymore, hence the capturing will proceed normally, or the sum of the 30 seconds reaches the wait time limit. In this situation, the car will be reported and the image will be sent to the server.
So, let's talk about the server and the database. Starting with the server, we had used a Raspberry Pi as a server, and we had written a Python and used socket to receive the violation image that came from the scikit board and stored in the Raspberry Pi. For the database, we had used a MariaDB database installed in the Raspberry Pi, and we used a Python and MySQL connector library to send SQL queries to the database to save the image path, the image information such as the violation type, either double bar or blocking car, the camera ID represent the camera that detects the violation, the date, the time, and the day of the violation.
After we have designed the system, the user must have an interface to interact with the server and display the violations. So, we developed a Java program to let the user check the violations with just a mouse click. The program will launch at first by letting the user log into the server and enter some information, including the DDNS link, port number, username, password, and the database name. When the provided data is correct, the main panel will be displayed. In the main panel, the user will see all the records of the violations, and he can display their images, move records to the handle table, or refresh the table to check for them.